Good morning. My name is Gary Goldberg. I'm with SSI Aeration. SSI provided diffusers, coarse bubble and fine bubble in your B&R basins, your sludge holding basins, and your re-aeration basins. I got a little introductory PowerPoint that I steal out of a training presentation, just kind of explain some of the basics about the system. And then I also have available the O&M manuals for all three of the systems. And so I'll call those up to look at certain things. Part of this is we want to go where you want to go so that you're comfortable with whatever your questions are. I want to make sure I answer them all, but I want to give you a good general familiarity with the system, make sure you know what the operating and maintenance issues are, and then how it's put together, what you got to do if you got to fix it. And as far as operational, we'll talk about how deep you want to go into operational and process. I'm not a real good process guy, but I fake it a little bit. So, and if not, I got people I can refer you to that can help you with that. If you got questions, feel free to interrupt me. I tend to ramble and shoot and chase rabbits whenever I think it's appropriate. So, but that's part of just, I go with the flow for whatever we're talking about. So, you guys have a lot of different facilities. I don't know how many, but you have several different facilities. You got 5 facilities I see from the back. There's 5. So in general, you guys are already familiar with the product a little bit. So this is a fine bubble aeration. It's a Teflon coated EPDM membrane. There's like 40,000 slits or something here, little 0.01 inch slits. This is what a diffuser looks like. Those fine bubble diffuser, those hook onto these saddles. We'll go into a little bit more detail. The coarse bubble diffusers are stainless steel, 24-inch long diffuser that's screwed into a nipple. And I'll pass those membranes around if you want to see what they look like while I'm talking. If you don't want to pay attention to me, I'll pass these other parts around. Well, I guess you could probably follow it with a diffuser for each of you too if you wanted. And I guess you could pass that stainless steel one around.
Familiar with these things.
So,
a little bit about the Teflon.
I will. I'm just ad-libbing at the beginning. So, well, I can do it right now. So, these are Teflon coated. This is a patented process that SSI started quite a few years ago. I think they were first in the industry to have this. It's just a little Teflon coating, kind of like your pans at home. The normal membranes are EPDM. If you look at the backside of that, it's just a black rubber. That black rubber, algae and biomass and mineral scale all sticks to that pretty hard. This Teflon, just like a nonstick pan, it cleans real easy. So sometimes you can clean it just with a hose, and but usually I just use a cloth or a cloth glove, just a couple swishes, and it tends to come clean. So the Teflon tends to stay cleaner and clean easier, and as a result of that, they tend to last longer. So it's something that they've chosen to invest in here. It's a little bit extra money compared to the EPDM. Some places they go cheap and try and save that little extra money, but it's a nice little feature they have here. So unless there's any other questions off the get-go, let me just crank through the boilerplate here just so you know. So SSI is a global manufacturer. Yeah, I'm kind of going to read, but they've been around since 1995. They're in Poughkeepsie, New York, is their headquarters, but they have facilities all around the world. They do a lot of fabrications in India, South Korea, Italy. The staff in the United States, the engineering team here, the lead engineer, a couple of lead engineers are from India. So if you do call and you're looking for help and you're talking to somebody from India and you don't get along with that dialect very well, they do have American English-speaking people that work there. So if you do ever call for help and you're having trouble understanding the people, just ask to speak to somebody that speaks better English, and they will give you to somebody else. But the head engineer is Indian, and if you've talked to people in that dialect, they seem to talk very fast, and unless you're used to it, they're hard to understand. So, but they're very competent to help you. They stock facility or manufacture stuff and have pieces all around the world. And mostly parts that would come around here would be from Poughkeepsie. But they are our fabricators They got a fabricator right here in Florida that puts together the plastic systems for them that I think you guys, well, the contractor has worked with before, that guy. So familiarization, I really just want to, I'm going to go over what the system looks like. I got some little diagrams. They aren't going to be what your system is, but I'm going to talk to you about what I call the pieces so we know what we're talking about. And they want you to talk about safety. I'm sure you get enough of that. So if you are doing anything in the tank, make sure you're following appropriate safety procedures. I think I got some detailed slides in here, but we're going to talk about all these subjects. This is a little picture of a basin. I think I got that in there twice. Yep. So, and I should have my little pointer here. So, this is a typical fine bubble aeration basin, and the naming of the components, the drop pipe into the tank, this pipe going across underneath, that's a cooling pipe. You don't really have one here. But when you use the blower and you have the heat of compression, but compressed air is hot. When it first enters the tank, it goes through that stainless steel line and it will be cooled in the water. When you have plastic components, you don't want the temperature to be over like 140 degrees or the plastic melts. So that's why they have a cooling line here. Apparently it's going to get enough cooling in the drop leg. They didn't have to have this cross leg in the tank. The big line that goes across the tank is called a manifold. And then off the manifold, there's headers. At one end of the other, off the manifold, there is a manual purge system. That's a pipe that goes down and drains water out of it. Actually pumps it up out of the manifold through the riser up to the top to a valve. I think there's a detail in here later that shows it. The joints on your project, you've got some flange joints, you got some coupling joints, which it's a solid stainless steel coupling. There's a picture of it in here. And then you also have kind of like a true union ball valve joint that's used to put together the PVC. It's a SSI patented piece that's it's got some little splines on it. I don't have one of those spare to show you, but pieces go together and it's got a nut on it just like a true union ball valve. The supports are stainless steel straps on all thread rods, and the quick connect saddle, and we'll go over it in a little bit more detail. This is an example of what it is, and apparently this is one of the features. SSI has a number of different ways of connecting these diffusers. You'll notice that there's threads on that, so it'll thread into a nipple. This is a big base that allows it to screw into this 4-inch saddle. So I guess I'll chase a rabbit right now just to do it. So this saddle, the PVC header has like an 11/16 hole in it that's big enough to, or maybe it's 1 3/16, whatever the size of this hole is here, that'll slip into the top of the PVC and that'll actually lock in there. This saddle, the one side of it acts like a hinge. You put it right around the pipe. It's got a gasket that's in it. You notice that this is a 3-dimensional gasket. It's got shape to it. It fits the contour of the saddle. You have to make sure that when you put that gasket in there, that you put it in, that the high sides are on the high side and the low sides are on the low sides. If you put it in crooked, and I'll pass this around to you, you'll be able to see it. There's a little ridge on this gasket that it actually does the sealing work. And if that gasket should happen to twist, and I think this particular one has a twist mark in it. You can see that it was in there twisted. It'll make a little tiny bubble and it'll leak. So when those are in the tank and we're checking for leaks, I like to describe it, it's like you farted in the bathtub. You just go bloop, bloop, little bubble of water that comes, or air that comes up from under the diffuser. And when we're doing leak checks, if it bubbles like that more than once every minute, we go look at it to see where it's coming from. There's a variety of places it can come from. That little ridge, I've had jobs where there's a little PVC shaving that when you put the pieces together, if you drag them across each other and you get a little burr and the burr lands right on that, if the burr lands across that, it'll leak a little tiny bit. So that's a process we're going to do to finish doing today, is to make sure that all of them are fixed, leak free. But that gasket goes in there on the high side. You hinge it together, put it over the pipe. It's got a little wedge that slides on it, and you take that wedge and a rubber mallet and you drive that home. And with that all the way on, that's locked on the pipe, and that's a pretty robust connection once it's on there. It's got some things that you got to make sure you do right. You got to make sure the wedge is tight. You got to make sure the gasket's in the right place, and it's got just a little tiny bit of wobble. If it's wobbled all the way one way or the other, it could leak also. So, but once it's on there, it's pretty robust. And also, just like that little gasket's got a ridge on it, this saddle has a little tiny ridge around it. That ridge, this gasket ends up sitting on top of it because the diffuser is going to go in there. The gasket has got the little notches in it. Those index right into the notch. And normally we would lubricate this with soapy water. Sometimes they have a bottle of soapy water or a bucket of soapy water. You can just dip the whole thing in there. I usually travel with a spray bottle, but I'm usually only doing 1 or 2 of them. So I'll spray that with soapy water, and then when it's on the pipe, it's hard to do because it takes a little torque. This has 4 little locking indexes around there. They're little J hooks there. You line those up with the slots. Oops. And naturally, you can't line it up when you need to, but you line it up, you push it down all the way until it's home. You want to push with about 30 or 40 pounds force and compress that gasket just a little bit, and then you give it a 1/4 turn, and it'll be locked in place. And that's a feature that this style gaskets, I guess the local vendor tells me you guys are pleased with this system. You like the way that it is, the robustness, the easy to maintenance. Because if you want to go down there and take those off, you can just crank them off. The rings on these diffusers, depending on how tight they are, you can actually loosen the ring rather than turn the whole diffuser. So you got to be careful to make sure that the rings are tight. But once those are in place and tight, well, one of the problems I have is if they push too hard or they don't lubricate it, that little gasket in here will actually distort when it's like it'll turn into like a little crumpled flower or something. And if that gasket ends up where it pulls it away from here, so it's only going to be on like half of that, and they leak. So we have to take it apart and fix it and put them back together. So we're going through all that right now to make sure that they all go together properly and that they're hopefully leak-free. But typically, anytime you take the system down and you get a chance to look at it as you're getting ready to bring it back up online, you're going to want to take a minute, fill the water right till where it's on the ridge of the diffusers, and then watch for those little fart bubbles. So,
And use soapy water.
yeah, soapy water to lubricate your gaskets and plastic parts. So, so in a nutshell, that's the Quick Connect saddle. They have they got a thing called pods. They have other places where they'll put a tap saddle on them, and they got places where they'll put welded saddles on stainless steel pipe and just screw those in there. So, yeah, I guess you've already had that. I need to send the saddle around for you to take a look at the saddle, and and you want the wedge too. Feel free to take it apart and put it back together. Any questions on that? So, you really, if you are doing maintenance and you take them apart, you just want to be careful that you're protecting that little upper ridge. If you take it and you step on them or lay a pipe across them or a piece of rebar, you're going to tend to be able to rough them up a little bit. So the hinge is the other side. There's a learning curve. So you want to hook the hinge first. Yep, you got to open it up a little bit, and then hinge it on there, and then the wedge goes on there. So, and then the diffusers, like I said, those go on there with the 1/4 turn. And the coarse bubble, they're threaded into nipples, and these should either have pipe sealant or pipe tape on them before they put them together. So, in a sense, so recap again, I got drop pipe, cooling pipe, manifold, and headers. I got a little blurb about storage. Typically, these parts are able to be good and stored for up to 10 years. They're better to be inside. If they're outside, they should be covered, but heat's their enemy for plastic parts. They tend to eat them up. The plastic might change colors from the heat or the sun, and unless it's really badly oxidized, it's not really typically a problem. I guess we kind of already talked about the parts, so I'm going to skip past there. This is just, this is not necessarily, this has got a different saddle than what your job is, but typical spare parts nomenclature. You got the diffusers, you got the diffuser holder, a plate and a ring. This special tool, that's made to fit those diffusers so you can take the ring on and off. And it is a special tool. I don't know what your spec said about providing special tools. On a great big job, they provide those. On a littler job, you really don't need them. You can typically put it all together without a special tool. If you were going to be changing the membranes in the future, the rings tend to tighten up over time, and you might need the tool in order to loosen the rings.
Does that tool completely encompass?
Yeah, it's a laser cut ring that fits those little dimples in the edges of that diffuser perfectly. And I don't know, some jobs they spec that all the special tools are be provided, but that's one of those things that shows up on about a third of the jobs. When they got a big tank with 6,000 diffusers, it tends to show up. So the pipe supports, like I said, those are just all thread rod with stainless steel straps, and I think there's a better picture of those later. This is a different type of saddle than that's a QTS saddle. That saddle is in two parts, and they actually just snap together over the pipe, and that has a threaded fitting that goes in there, and once those are clipped home, hopefully they're good forever. So that's also pretty robust, but it is a little newer model. But a lot of people like this quarter turn one instead. And this is a picture of those true union joints. It really does look like a true union ball valve type of joint. I wish I had one that I could have you touch, but they're all on the tank. I was going to talk, yes sir?
Did you mention if there was some special dope or something to put
Okay,
on that?
all of you've been to the Sanitaire class. The Xylem class. Xylem, Sanitaire, when they put their membranes together, they put some silicone grease on them. They put 4 dabs of silicone grease on the edges of the membrane, and when that ring goes on, they lubricate it with silicone grease. SSI, just soapy water. Any of our products, unless like pipe threads, are typically just lubricated with soapy water. Plastic on plastic, soapy water. Plastic will gall just like stainless steel will. So you want to put the soapy water on there to keep it from galling until it gets all the way tight. And some of our stuff, when it goes all the way tight, they kind of want it to kind of take a little bite into itself so that it won't back off later. So no silicone grease, it never seize. Every once in a while on those true union joints, I tell them if you want to lubricate those joints with some pipe dope, just in case you have a little leak, that's a little bit more forgiving, but typically soapy water is all you need. Those couplings are made so that they're using a strap wrench to tighten them, but you can really get them, if you do them hand tight and you get the good last oomph on it, they're tight. So no lubricants other than soapy water for SSI equipment. So I was going to talk about the saddle installation, but I already did that. So diffuser installation, that's, like I said, they push those in with a quarter turn, and like I said, you want to push down with 20 to 40 pounds of force and turn it, because you need to compress that gasket just ever so slightly in order to make sure that it's not turning, doesn't twist in there. So, and the coarse bubble ones, like I said, you pipe thread, and when you screw those in, and I haven't been in this tank yet, so I don't know how it necessarily worked out, but usually you got to put enough pipe thread or pipe dope on here. You want this diffuser to actually tighten up when it's round side up, pointed side down. That's the right way for it to be installed. And you want it to get tight so that it snugs up on the threads right when it's in the right position. So usually you got to make sure you put either the right amount of pipe dope or enough pipe tape on there that you can just get it tight. Because if you leave them loose, they'll vibrate and fall off, and someday you got to go pick them up out of the tank. This is a little blow up of the supports. SSI has 2 different types of supports. They're the same support. The fixed support is on the one side, and you see the straps are just right together. And that's supposed to be fixed, and it grabs the pipe tightly, and that's used for any of the drop leg supports and the first support on the headers off the manifold. That locks the pipe in place there and lets the other ones float. The guide supports have 3 extra washers between the straps, which makes them fit a little looser on the pipe, so if there is any thermal growth, it just pushes it towards the end of the pipe. And I think on your job, this says adhesive anchors on the bottom, but I think your job is all done with drop-in anchors. So the supports are pretty simple and standard. This is a stainless steel coupling that you have in your coarse bubble tanks in some locations, I think. I'm trying to remember that. Yeah, I'm pretty sure that's correct. I can't remember at the moment how many there are, but they make those in different sizes. Those couplings, the couplings we provide are called peel couplings, but they're like a Straub coupling. So it's a stainless steel with a rubber sleeve in the middle of it, and you can see the little ridges that are on the inside of that. Those are pretty forgiving. They're very easy to seal. They got a torque rating on them like 15 to 20 Newton meters, and basically if you put a wrench on those and tighten them just a little bit, they usually won't leak. Those are pretty good couplings. And then you also have flanges on your you got some PVC flanges, some stainless steel flanges, so typical flange construction, gaskets and nuts. Talk about that union. joint instruction. There's an O-ring in the middle there. You got to make sure that O-ring is there, otherwise they leak like a sieve. And the way these are designed, they're machined such that the coupling has to go almost all the way tight before it'll actually pinch that O-ring and seal. So you want to make sure the O-ring's on there, and when you put that ring on there, when you're looking at the coupling, you can see the two different portions. Once it's all the way tight, it's actually flush on the end. If you got threads sticking out, it's probably not all the way tight. So they're using a little strap wrench to give it the last size. So hand tight, and then they're putting the strap wrench on it and tighten it like about 1/8 of a turn. And again, soapy water on the threads, or a little pipe dope sealant if you feel like it. So the O&M manual is all very good. All these little blown up pictures, there's a step-by-step thing about how to put together every piece. This is just going into typical aeration tank installation. I'm probably just going to blast through there. This is that moisture purge system. So on the fine bubble diffusers, you have a moisture purge system that's on the manifold. The way that's built, there's in this little exploded view, there's a dip tube inside the pipe. It's got a little 45-degree slit at the bottom, and up at the top of the pipe, there's a little tiny hole. My arrow's all over it, and you can't see anything. But there's a little tiny 1/8 of an inch hole up at the top of the pipe. So that lets air into that. Even if the header's flooded, it lets air into that, and it'll pick it up and lift it. It's an airlift pump, essentially. It makes a stream of bubbles through the water, and the bubbles moving up bring the water with it. So if you get any, they're primarily supposed to remove condensate from the pipe. And you probably have these at your other facilities. So if you get condensate in the pipe, eventually if you make lots of condensate, you could flood the whole system out and it won't work right. So periodically you need to open up that purge valve at the top to let out any condensate you might have in there. The O&M manual is kind of peculiar. Down here at the bottom, this says moisture purge system periodically every 2 to 3 months. I had a job on the other side of the state over here in Florida that they pretty much left theirs open all the time because it was extremely humid when we were doing startup. It was making condensate all the time. So some places need to leave it open all the time if it's really humid. What I usually tell the operators is it's just like if you're doing rounds on a air compressor drip trap, or if you got digester gas drip traps. If you're going by there, you just open it up, see what you get out of it. And if you never get anything, then you might decide to do it instead of daily. You do it once a week. If once a week's too much, then you do it once a month. So I try and urge that you put that moisture purge on your rounds when you're walking around. If it lets you know what's going on inside the system. If you open up, it's going to make some mist, and then maybe a few glugs, and then usually it'll dry up. Typically it should be clean water because it's condensate. If you turn that on and you get black water out of it, it means you probably got a leak in your system somewhere, and that means trouble, and you got to probably turn it off and fill it up or drain it and repair it. So if you are turning the system on and off, the way those diffusers are built, there's a little hole in the middle, and that membrane gets pushed down, and it's just like a check valve, but it's not perfect. So for a short period of time, that'll keep the water out of the system. It'll probably keep the sludge out, but the water will eventually migrate past there, and you'll be able to get a little bit of water in the system over time. So if you have a tank offline for a long period of time, and you're going to turn it back on, you're going to want to open that purge valve to help remove any accumulated water that's leaked into the system. Turn it on, and when it stops gurgling out, glug, 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 then you can close that and go back to operating it on a normal purpose. So this is one of the maintenance tasks and an operational observation tool that you got control of. So it's a pretty important thing. It's one of the main things you have. Any questions about it? You familiar with what they are and how they work? I got silence, so okay. Replacement of membranes. This picture actually shows over in the corner here, there's a metal jig that they've got. That's designed where you can actually take the bottom of that diffuser ring. If you flip one of those over and look at it, you can see how that star shape in there has those little stars in there. That'll fit right into that ring in order to so that you can then hold that in place and you can turn it. On this job, you can do it in place. if you put the wrench on there, or if you spin the ring backwards, you can take it and it'll turn back that little quarter turn in the saddle, and it'll go backwards against the stop, and you can loosen the ring, and then you can take the ring off and you can change the membrane, put it back together, and then retighten the ring. That's one way of doing it. The other way you can do it is you can just crank through them and take them out of the tank and do them up in the bench in the workshop. Some places where they replace the membranes, they'll actually buy a whole extra set of diffusers for the whole tank. So in your tank, you got like 210 diffusers in it. You have 210 extra diffusers. You go down there and you change all the diffusers out in them as a whole run, and then in your spare time, you take the 210 up in the shop and you spin the rings off and you put new diffusers on them, and then you'll be ready to redo the next tank if you want to. So if you are going to be doing them in the shop, you're either going to want to build one of those jigs, or you could even just use one of the saddles mounted on a piece of pipe and do it itself. The saddle will do it, but when you're doing 200 of them, the saddles tend to wear a little bit, so the little metal jig that they drop in is fine. You can also make one of those. You can take like a 4x4 and you can just cut the right slots in it. So if you're crafty, your maintenance guys can probably make one of those on site if you need to. SSI does have one like that they ship around the country for people to use. And if you do need the wrench, they'll ship you one of those too. And replacement of membranes, typically your membranes are going to last 5 to 10 years. Depends a lot about how hard you push them. Yeah, you'll be gone. Yes, sir.
Do you have an idea how much 200 of those replacements would be? Off the top of your head?
Well, you guys are fortunate enough to have a priced out parts list in your submittal. So,
5%. No, 5.
yeah, you're gonna get. It says 10, but you probably got 200 laying back there right now. There's probably 50 at least. There's 24 in a box. A diffuser assembly is $13.15. And I don't know if that includes the membrane or not. The membranes themselves are $7.65. So for $20, so $4,000 for sure. And I'm not smart enough to tell you how to. Kevin, you know how to price the spare parts yet?
I'll learn.
Yeah. So in the O&M manual, it's listed there. So it would not be more than $4,000 to do it. And then rather than doing those down in the tank, you can go down there. You can put. How fast did they put those diffusers on? A couple hours. Yeah. So you could go down there in a matter of half a day. You could take them all off, put the new ones on, and then at your leisure, do those, because a lot of places they'll stagger when they do those replacements. Here you're small enough, depending on how fast you're going to be able to get in and out of there. But it wouldn't be bad to have a whole set of spares and then do them like that.
Would we be locked into that cost in 5 to 10 years?
Above my pay grade, so the way things go, no. What they guarantee you is that for any particular system that they are going to stock those parts from 10 years from your purchase date. So if they change something, they'll still stock the old parts for 10 years. So you're going to have availability, but what the price is, I can't necessarily speak to that. I'm not in the parts department. I rarely see the price on that. So when I see that, it just makes me. I think one of the last prices I saw, they were only $2 or $3 a membrane, but I think that might have been for the EPDM ones. The Teflon's only like $1 or so extra a membrane. So, any other questions? Operation, they just wanted me to touch on operating principles. Normally you're going to adjust your blower rate to achieve probably the DO. I don't know how much control you have here or not. If you're doing grabs for DO, I know you got a variable speed blower. It looks like you're going to have a blower dedicated to a tank, and you'll be able to control it to match the DO. Those diffusers are typically rated 1.5 to 3 CFM for the fine bubble diffusers, and peak flow they say 7. They tell me if I want to take them to 9 briefly I can. There is a little orifice that's in the middle of those that balances the airflow across them. I'm under the impression it takes about 1 CFM to balance it across all the diffusers. So if you're putting in if you got 200 diffusers in your tank, if you're putting in less than 200 CFM, you might see a dead zone on the end of the tank. There might not be enough air to go around. So I think in the O&M manual it's got your calculations. I haven't looked at them. I just fake it, but that's what we find in a lot of places, they've designed for the peak rate, and you're going to end up probably having a little turn down, and that's what you're going to see. If your DO is satisfied and you're not getting air diffused all the way through your tank, you might just have to periodically turn your tank up a little bit. So troubleshooting, things you want to watch for. Normally a fine bubble tank just has a big swirling mass of little fine bubble foam. And if you got a break somewhere, you have a big pile of coarse bubbles coming up. And I'm sure you guys, if you got aeration tanks, you've seen what a coarse bubble boil is. Our recommendation, if you got a coarse bubble boil, is leave the air on and drain the tank. You don't want to start and stop the system, because every time you put sludge inside the system and it comes out, it gets wedged up between the membrane and the diffuser frame, because it won't go through the membrane, and you'll collect those solids up there and eventually make it so that the membrane's totally defeated. So you have to, that's the main thing. If you got a leak, leave the air on, drain it, and fix it. That piping system is all made of Schedule 40, well, Schedule 40 pipe. You got some Schedule 80 manifolds, and you got some stainless pipe, but the typical headers are Schedule 40 pipe. You can put together with solvent weld fittings. You can put together with Ferncos. So it's easy to work on if you do happen to break something. So depending on how good your air system or your telemetry system is, if you're keeping track of your blower back pressure versus a standard flow rate that you have all the time, you might see an increase in differential pressure over time as the diffusers wear. So, and DO is what you're really going to do. You're going to modulate it to maintain your DO. So a little chart of what they want you to check every day. You're going to keep track of the operating airflow, pressure, and DO, just your normal operating parameters. Anytime you're looking at the tank, you're going to look to make sure it looks uniform. You don't have that boil. Make sure that air is coming out everywhere. Watch out for those coarse bubbles. The moisture purge, this one here says once in a week. See, they can't make up their own mind what they want to do. I still say, when in doubt, do it once a day until you get familiar with the system, then do it once a week. Another thing that we can do is air bump these things to help clean them. So these things work, I wonder if this one's clean. These things work a lot like Jiffy Pop. When you blow on it, it pops up in the air. So the more air you put in it, the higher it blows up. So if you're running it all the time at 1.5 CFM, it's going to have a little dome on it, and it's going to collect some biomass, it might have mineral scale, and it might tend to start blocking those little pores. So one of the things you can do is periodically take the airflow and just like double it for 20 or 30 minutes. So stretch that membrane out, make the air velocity rip through those little slits and tear off any little particles it can, and just the process of having that overinflated for 20 to 30 minutes will help clean it. And that's something that some places will do it once a week, some places do it once a month, some places do it never, some places do it every 6 months. Some places got lots of instrumentation and they know a little better. They can see that they're getting more differential pressure. Here, you're probably not even going to know. You're just going to run the blower a little harder, and you probably have a hard time knowing just how dirty these are. So, but that might be something you want to consider. There are places where they automate that. The computer control system is actually just periodically run that blower all the way up and run it harder. So it's something you can automate if you want to. Your engineer and maybe your vendor might help you with that if you decide you want to do it. We just happen to have the vendor present, which I guess many of you guys know because he used to be a slave. So, and then cleaning the diffusers, they typically recommend that you drain the tank and clean it once a year and inspect everything to make sure it's put together right. In situ cleaning of the membranes, there are ways to be able to clean these. Like I said earlier, with these I just use a glove or a cloth and wipe them off. You can use a garden hose. You don't want to pressure wash them. If you do have built up a scale or even some of the right, I don't know if any other plants might have had the stones that they used to have way back when. Any older guys might have had aeration tank stones. Okay. Well, sorry, pardon me. But they used to have little like pumice stones that they blew the air through, and every time you turn the air off, the water would get pushed back through there. Those, they had a system where you could blow acid into the and actually clean the pores out of them. And sometimes they take those out and they'd boil them in acid to make them better. They do make an acid scrub that you can spray on these. It's not really acid; it's a fake acid, and that'll help clean up any scale if you do have hard water scale that gets in the stuff. They also have another system where you can actually inject it into the system on the drop leg and be able to blow it in there, but that's above and beyond the scope of what you use. So acid washing is something you can always do to clean them if you have to. It's all the same stuff. Biological buildup like moss. It's algae or moss that's on there. The minerals are going to be little white scaly spots that'll be on there. So I really just blew through most of that stuff. So things that you might have trouble with: poor air distribution. You got dead zones in the intake. Like I said, if the air ramps back as you're running it, you might have air not going all the way out to the end of the tank. You might start to accumulate some solids in those corners. So you might want to periodically stir it up in order to turn it up just to keep it from doing mounting or excessive air in a location. That's typically, again, a coarse bubble blower, a coarse bubble boil, and you'll want to drain that. Excessive discharge blower pressure. The blowers are going to just take care of themselves. I think you get too low pressure, too high pressure, they'll just shut down. Excessive solids in one tank. That's, again, if you got not enough air to keep all the way out to the end, you're going to tend to collect solids in those corners. When you do go to drain the tank, you're going to have the air on to keep it stirred up to try and get as many solids out of the tank as you can. And every once in a while you get too much solids in your mixed liquor. So if you're doing that, you're not running the plant right. So this is not the slide you want to look at, because your local representative's really at the back, because I stole this from some California job. So Kevin Vickers in the back is your local rep.
Hayward, Florida.
From Hayward, Florida. Yep. So that's your quick one through on the overall presentation. That was geared to the fine bubble. This is the coarse bubble. What time do we have here? So I do have the O&M manual available, that if we have any questions, I can bore into that and find pictures to show you exactly what you want to see. But the one thing that's special on this tank, these in your sludge holding tank, you've got mechanical mixers. So you've got a PVC header with a T in it and a PVC fitting in the bottom of it. That has a stainless steel bushing that's in the PVC, and then there's a stainless steel T that these are threaded into, and they go both ways. On the outboard end of these have an extra pipe clamp that's similar to those saddles, except the top is a strap and the bottom is a V, and that holds these in place. And on each, there's a pair of these together on a T, and that holds these in place to resist the loads of the mixer blowing at them, making force across the bottom of them. So that makes these a little bit different. Those are there to keep them in place and to keep them rigid in place. When you are in there working in that tank, if you were in there trying to shovel out the tank, at the end of every one of these you got a tripping hazard that you can hook your foot on. It's hard to shovel under and all that other type of stuff. So I think I could show you a picture of that back in there if you want to see them. But well, that's you want to go out and give them an opportunity to go out and look in the tanks, right?
Yeah, that's it.
If they want to. So I don't. So I know that was kind of a little quick and kind of blew through some high parts, but really, like I said, it's about orienting to what you guys want to know. So what haven't I talked about that you'd like to know, or do you want to just go take a peek at them?
Let's go look at them.
Where'd you get them boots?
Amazon.
Get the boots, boy.
$79, steel-toed hip waders.
No, I like them.
They're well. This is one of your sludge holding basins, and sorry the water's a little dirty. It's kind of hard to see the diffusers down there. You can see the shadows of them. So as I said, it's a Schedule 40 PVC header. It's got a Schedule 80 PVC T, and then there's a PVC or a stainless steel bushing in the bottom and a stainless steel T, and then those diffusers are threaded into the T, and then on the outboard end is that extra support to hold them in space, because you got the mixer over there in the corner. We're getting ready to go down in here. I need to measure it, make sure it's level. Some of those couplings weren't quite tight, so they're going to tighten up a couple of the couplings, and we'll check everything else, make sure it's ready to go. This one also has an end cap on the end of it. It's one of those True Union end caps. I forgot to mention that. But same thing goes, it's just a little end cap, got the O-ring in there. And you can see the exposed stainless steel coupling that's down there. And that coarse bubble, those are rated at like 20 CFM. So this will keep your sludge holding tank actively mixed and a little oxygenated. Usually you're just looking for mixing, I think. Any questions about the sludge holding tank? You got a little smaller one on the other end of this, and then over in the corner there's a re-aeration basin that's got two little small sections there. That's an all stainless steel system. If you want to look in those, this one's still got an awful lot of water in this small one here, so you really can't see much. If you want to see it bubble, we can turn it on. Somehow or another, we lost the blower at some point in time. So if you wanted to go take a peek in those re-aeration basins once you're done with your artistic photos here. Unless they want to move right over and look at the fine bubble. I guess they're all around the fine bubble, so. So this is what you guys call a BNR basin. If you ever go in there, remember there's a big sump right in the middle. It's a 2-foot deep sump in the middle of the tank there. You don't want to fall in that. We've got the water level down here so that we can see that it was all level, and when the air was on, you might see some orange tape. We got some leaky diffuser to saddle connectors. We're going to go back in there and change those out to make them be good ones. But you can see the moisture purge system coming up the wall over here. We got the valves open right now, and any questions? You want to see it make bubbles?